everyone. We're going to find the area of the region bounded by the given curves of y equals x squared and y equals 4 times the square root of x minus 3. We also have x equals 0. All right, so let's look and see what we have. We have y equals x squared. So basically I'm going to take my y equals 4 square root of x minus 3. And now that my y is x squared, I'm going to substitute this for x squared equals 4 square root of x minus 3. All right, from there, I'm going to go ahead and add the 3. So you get x squared plus 3 equals 4 square root of x. If you square both sides, you're going to get, x to the power of 4 plus 6x squared. I'm trying to do this mentally. Minus 16x plus 9. This is your 16x right here. And set it to 0. Now, I'm just going to say, just looking at this, if you have y equals x squared, and you have y equals 4 square root of x minus 3, you can just mentally look at this and see that one of the intersection points is at x equals 1. You substitute in 1 here and 1 here, you're going to get y equals 1. So that's an intersection point. So what you also can do is use this synthetic division, and let's look at 1, and look at 1, and then 0, because we don't have an x cubed, 6, negative 16, and 9. And go ahead and use synthetic division. Bring down the 1, multiply and add, multiply and add, multiply and add, and then we get negative 9, you get 0. So it's a factor. We could do it again, and when you do it again, we're going to copy down. I'll just put it right here, since we already have this piece, so I'll put the 1 here and bring down the 1. So we're going to multiply and add, multiply and add, multiply and add, and you get to 0. So basically what you get is going to be x minus 1 squared, because we did this twice, has a multiplicity of 2 times x squared plus 2x plus 9, and this is not factorable. So basically our hunch was right. Our intersection point is x equals 1. All right. Now let's go ahead and sketch a graph of this. If I sketch a graph, the y equals x squared is easy. So I'm just going to sketch that. And this one right here is the curve. It's going to, we're going from 0 to 1. So I'll make this 1 here. And this is going to come up through here. Something like that. All right. So basically, and then it's going to touch in here somewhere. At negative 3 here. That's your y-intercept. All right. So the area that we're trying to find is right in here. This point right here is when your y is 0. So when y is 0, you're going to have 0 equals 4 square root of x minus 3. That gives you 3 equals 4 square root of x. And so that's going to be 3/4 equals square root of x. And when you square both sides, that's going to be 9 divided by 16 equals x. So that's this point here. We really don't need it, but I wanted to show you that. So anyway, this is the area we're trying to find from 0 to 1. So you set it up from 0 to 1, and the upper part, since we're doing our x axis, we're going from top to bottom. So from this shaded region, I don't like how this is turning out. So for this shaded region in here, the bounded from the upper curve is your x squared. So that's what you put first, x squared. Now from the bottom, it's bounded from your blue line here, which is your 4 square root of x minus 1. So you're going to subtract that, 4 square root of x minus 3. And then you put dx. Okay, so let's go ahead and evaluate this. We're going to get 1/3 x cubed minus 4 times 2/3 x to the power of 3/2 plus 3x, and we're evaluating this from 0 to 1 after our integration. So substituting in your 1, you're going to get 1/3 minus 8/3 plus 3, and this is going to give you 2/3. And so that's your area of that shaded region. Thank you. Have a nice day. Bye-bye.